Hi, it's Ryan. We're going to continue our discussion on forces. And we're going to do that by talking about types of forces. In general, our forces are going to be broken up into two main categories. We'll have contact or mechanical forces and action at a distance forces. So we'll start by defining our mechanical forces. Another way to think about a mechanical force is a contact force. And so the first one we're going to define for you is called the normal force. The normal force. The normal force is a contact force, which obviously, but it's anytime there's a force between two surfaces. So we'll say a contact force between two surfaces. It gets the name normal force because it's always normal to the surface. It's always normal. All that means is orthogonal, which is a fancy word for perpendicular. To the surfaces. That's why it's called a normal force. And so the best way for you to experience a normal force is to take your hand, either of your hands, and just set your hand on the desk in front of you. Do you feel a force from that desk? And what way is the force on your hand due to that desk? And you can really feel it if you start with your hand on the desk in front of you, and then you start to push a little bit. As you push, you're pushing downward, and that means that the normal force on your hand due to the table is pushing upward. And you can feel that as you start to push harder. It pushes back in the upward direction. And wouldn't you know it, that force is going to be equal and opposite to the force that you're applying. So you're applying a normal force to the desk because your surface of your hand is touching the surface of the desk, and the desk is applying a normal force on your hand in the opposite direction, which would be up. We write normal forces in this way. I usually write it like this, an N with a vector symbol, but oftentimes other people or books write F sub N with a vector symbol. Those are the symbols we'll use. Either one is fine for normal force. Next is tension force. A tension force is anytime a force is transmitted through a body. So we'll say whenever a force is transmitted through a body, and we could say undiminished, and example, we'll say usually we use tension in strings, ropes, chains, etc. So if you play tug of war, people on both sides of the rope are pulling. They're creating a tension force, and that tension force is transmitted undiminished through the rope. So it feels like you're pulling on the people on the other end of the rope, even though really you're only exerting a force on the rope itself. So anytime we have strings or ropes or chains or something hanging in a problem, then we know we'll be using a tension force in that problem. Another contact force is friction forces. Friction comes in two flavors. Friction comes in static friction or kinetic friction. Static friction, we give static friction F sub s equal to mu sub s times the normal force. And kinetic friction is F sub k, mu sub k times the normal force. So we could say where mu sub k or s, that's the coefficient of friction. And I'm going to give you a handout that will describe this a little bit more. So I'm not going to spend more time in the video, but this is really described in more detail for you in that handout. The most important thing for me to tell you is that kinetic always refers to moving bodies and static always refers to stationary bodies. And so in general, when we talk about kinetic friction, that means that the surfaces are moving relative to each other. And so what I'd like you to do is take your hand, put it back on the desk, put a little bit of a force downwards so you can feel that normal force from the desk pushing up, and then slide your hand along the desk. If you do that, you'll feel a force pushing in the opposite direction as the way that you're sliding. And as long as your hand is sliding on the desk, that would be a kinetic friction force. That means the surface of your hand was moving relative to the surface of the desk. So anytime there's sliding, the body sliding along will experience friction, and we would call it kinetic friction. Static friction is when the two surfaces are stationary relative to each other, or we could say, I like that, the surfaces are stationary relative to each other. So now what you could do is take a piece of paper and put that piece of paper on your desk, and then put your hand on top of the piece of paper so you feel a normal force on your hand. And now if you try, you could slide the paper so that your hand and the paper slide together, but the paper slides across the surface of the desk. When you do that, the paper's surface will have a kinetic friction force between the paper and the desk because the paper's sliding along the desk, but the force between your hand and the paper, the force pushing the paper in the direction that you accelerate it, would be static friction. So there'd be a static friction between your hand and the piece of paper, and there'd be kinetic friction between the paper and the desk. Can you feel that? So friction is a contact force between two surfaces, but and so there's one more note we could make. So friction always opposes the direction of motion or potential motion. So let's think about your hand on the paper again. So here's the desk. Here's the piece of paper. And here's your hand. Kind of looks like a foot, but that's your hand. As you push the paper this way, so you give the paper some velocity, that paper will have a friction force on it due to the table. And if it's moving this way, like we drew, then the friction force will be opposing that motion. The friction force on the paper will be that direction, Fk on the paper. Maybe I'll do that in a different color just so it's obvious. But there's also a friction force between your hand and the paper. And this one's a little more challenging to think about because this one's static friction. Your hand was sticking to the paper. And so the static friction will oppose the potential motion. So can you imagine if you didn't hold the paper or have enough force on the paper to slide it with you? Then your hand would move this way and the paper would move this way, and you would have the same sort of kinetic friction happening. But in our case, your hand sticks to the paper, so your hand and the paper are both moving this way. And so that means your hand is exerting a static friction force on the paper, F static on the paper. And that's what causes the paper to move in that direction. That also means then that the paper is exerting a static friction force on you that's equal and opposite. Static friction on you, I'll put a Y for you. But something to note is that this friction is on the paper, this friction is on the paper, this friction is on you, and so they're on different bodies. But anyway, that's kind of an easy example that you can actually feel some of these properties that I'm talking about when it comes to friction. And those are the mechanical forces that we'll be using in our class. I guess there's one more. I guess we could mention that, of course, there's the spring force. Anytime we have a spring, we could talk about the force exerted by that spring, and we use something called Hooke's law. Hooke was actually one of Isaac Newton's mortal enemies. But Hooke's law states that the force due to any spring will be equal to the spring constant times the stretch of that spring. So K is defined as the spring constant, and S is the stretch. And so we could note that S is equal to X minus X sub O, where X sub O is the unstretched length. Oh gosh, sorry, I was thinking about using different notation. Unstretched length. A little thing, oftentimes books will put in a negative sign in here. I don't like to do that. I like to let my picture decide if the spring force is in a negative or positive direction. So I don't ever put the negative sign in my definition for Hooke's law. But it doesn't mean that it's wrong or that someone else has it in a wrong way either. I just like our picture to decide negative signs for us. So that's our last contact force. The next type of force are often referred to as spooky forces, but they are called action at a distance forces. Action at a distance forces. And what that really means is that these are the forces that reach out through space-time with invisible arms and affect bodies without seeming to be able to touch them, or without touching them at all. One of the most fundamental of these forces, the one we're going to use the most in Physics 1, is the gravitational force. Gravitational force. When Isaac came up with his universal law of gravity, he gave the gravitational force like this. And so we could say where G is the gravitational constant. R hat is the unit vector. It gives direction. M, that's mass, and R is the distance between M1 and M2. I'm not giving much on this because we're really not going to use this for our class. We represent the gravitational force as something called the weight force. So we always approximate this force in our class. We approximate it using the weight force, where weight is equal to mg. And g is the acceleration due, well, no, let's not say that. It's not an acceleration. It's the, so yeah, I don't want to have these either. This is really just magnitude, and we let what we know about gravitational force give us the direction. G is the constant associated with the acceleration due to gravity at the surface of the Earth. And so we should note G is equal to 9.81 meters per second squared. And notice that's not negative, and it never will be negative. Never negative. If our weight force is negative, it will point in the negative direction, and we'll let some of our other tools for solving force problems get us there. So this is a constant associated with that. This is not an acceleration, and so it is not a negative value. That's a place that students often make mistakes. So that's the most, that's the action at a distance force that we're going to use the most, and especially in Physics 1. The other two don't come till Physics 2, but they're the electric force and the magnetic force. And so we'll save discussion on those for a later semester. So those are our types of forces. And we're going to teach you how to use and solve those forces and force problems in the next one.